Hello, this is Miss Ginsburg with KnowAtom, and today we're going to be reading Molecules to Materials. This is a lab manual in Unit 1. Intro section, Material Science, Mimicking the Stickability of Geckos. On a cold December day, an engineering student named Elliot Hawks acted like a slow-motion Spider-Man. He inched his way up a glass wall behind his science lab. He was able to stick to the glass because he was testing a new kind of material that was attached to his hands and feet. The material used by Hawks to scale the glass wall was designed by humans to mimic gecko feet. Geckos are lizards that can stick to almost any surface they walk on. They can run up smooth walls and across the ceiling without falling. This stickability is called adhesiveness. It is a property that gecko feet, glue, and tape all share. How geckos stick. Geckos are able to stick to most surfaces because of their unique feet. Their feet are lined with millions of tiny hairs called setae. The setae create an attraction between the gecko's feet and the surface. Unlike adhesives such as glue or tape, the gecko's sticky feet can attach and detach from the surface easily. This means the adhesiveness doesn't have to be permanent like glue. Here's a gecko clinging to glass. Gecko's feet are lined with millions of setae. The stem cycle. Scientists are so intrigued by the gecko's adhesive feet that they have been trying to mimic it. They want to use it in applications as common as wigs and toupees that remain in place, and as cutting edge as robots that can catch space junk, such as satellites that are no longer working, and gear for soldiers so they can climb walls without ladders. Researchers such as Hawks, who use scientific knowledge to design a technology such as the gecko-like hand-size adhesives, are a good example of the STEM cycle in action. STEM stands for science, technology, engineering, and math. Science is all knowledge learned from experiments. Broadly, science is the search for explanations about the natural world, and scientists use evidence to form conclusions that support those explanations. Engineers then use the scientific knowledge to design new technologies that solve problems. Math is a tool that both scientists and engineers use to capture results and to communicate those results to others. Here's the STEM cycle. Science, technology, engineering, and math are connected in the STEM cycle. The field of science that focuses on the relationship between the structure and properties of different materials is called material science. Materials are substances that are designed to be used for certain applications. There are currently more than 300,000 different known materials. Some, like wood, are naturally occurring. Others are synthetic. This means they are formed through a chemical process developed by humans, as opposed to those of natural origin. As scientists create and combine materials in new ways, that number continues to increase. Material scientists look for connections between the underlying structure of a material, its properties, how it can be changed, and what it can do, its function. Structure is the way in which parts are put together to form a whole. Function is the normal action of something or how something works. A material structure is directly related to its function. Researchers like Hawks are interested in creating materials that have a set of properties that will allow them to be used in a particular way. A property is a measurable or observable characteristic of a substance. The scientific process. In order to answer questions using evidence, scientists follow a process that provides them with a logical framework to work through the question. A process is any series of steps designed to meet a goal. The scientific process guides scientists in developing a replicable experiment as they seek out answers to questions about the world around them. There are 8 steps that scientists often follow to answer questions using data from experiments. Step 1, ask a question. The scientific process always begins with a question. Scientists look for the causes of different phenomena they observe in the world around them. For example, One question that scientists interested in the gecko's ability to stick to different surfaces might want to answer is, how does the number of CT, hair, on a gecko's feet affect its adhesiveness? Step 2, research the question. Scientists conduct hundreds of thousands of experiments every year. Every year, the amount of scientific knowledge grows. Scientists use this existing knowledge to research their questions so they can find out what is already known about their question. Step 3, form a hypothesis. After scientists have researched their question, they form a hypothesis. A hypothesis is a statement that can be proved true or false. The hypothesis is the scientist's prediction based on what is known about the answer to the question. Two examples of a hypothesis are, more CT on a gecko's feet increase the gecko's adhesiveness, or fewer CT on a gecko's feet increase the gecko's adhesiveness. Step 4, write a summary of the experiment. Scientists then write a summary of the experiment they will conduct to test their hypothesis. The summary should include the basics of the data to be collected, the variables that will be tested, and the parts of the experiment that will remain constant in each test or trial. A variable is something you change. It can be a factor, trait, or condition that can exist in differing amounts or types. There are independent and dependent variables in an experiment. The independent variable is what the scientist changes. The dependent variable is what happens as a result of the independent variable. For example, in an experiment testing how the number of CT on a gecko's feet affect the gecko's adhesiveness, the independent variable would be the different number of CT on the model gecko's feet. The dependent variable is what happens as a result of the independent variable. For example, the adhesiveness of the model feet is the dependent variable. Constants allow scientists to isolate one variable at a time to ensure the experiment results are valid. For example, the size and shape of the gecko foot would need to be constant, as would the kind of material the surface is made of. If any of these factors differ, it would be impossible to know whether the results were because of the number of CT or another factor. Step 5, list materials and procedure. Scientists then list materials needed and the procedure they have created that they will follow. A procedure is like a recipe. Whenever you use a recipe, you are following a careful and precise procedure that someone else developed. Scientists write down their materials and procedures so anyone can use the same materials and follow the same steps to get similar results. They also want to create a record of their thinking. Step 6, draw a scientific diagram. They will also draw a scientific diagram. The diagram helps the scientists visualize how the different materials will interact in the experiment. Step 7, carry out experiment to collect data. Scientists then collect an experiment to see their hypothesis, conduct an experiment to test their hypothesis. An experiment is a specific procedure that tests if a hypothesis is true, false, or inconclusive. Scientists use experiments to look for patterns in data that suggest a cause and effect relationship, where one event or thing is the result of the other. A pattern is something that happens in a regular and repeated way. The results of the experiment are data. Data are the measurements and observations gathered from an experiment. Step 8, form a conclusion. After data have been collected, scientists form a conclusion. The conclusion uses data from the experiment as evidence to support whether the hypothesis is true, false, or inconclusive. For example, after conducting an experiment to investigate how the number of CT on a gecko's feet affects its adhesiveness, scientists might discover that more CT make the gecko's feet more adhesive, or they might find that the number of CT has no effect on adhesiveness. This would tell them that another factor must be responsible. They would need to conduct more experiments to collect additional data. Using a scientific process. 1, question. End with a question mark and do not include words such as I or because. 2, research. Include a minimum of 3 facts relevant to the question. 3. Hypothesis. Write a concise statement that answers the question and can be proved true or false. 4. Summarize experiment. Describe in 2 to 3 sentences the experiment you will do to test your hypothesis. Identify the independent and dependent variables, constants, and controls of the experiment. The independent variable is the variable changed. The dependent variable is what happens as a result of the independent variable. Constants of the experiment are conditions unchanged during each trial. A control in the experiment captures the effect of unknown variables. 5. Materials and procedure. Vertically list all materials needed for your experiment with quantities. Next, vertically list the numbered steps of your procedure. Note safety precautions. 6. Scientific diagram. Draw a diagram of the experiment setup that is at least the size of your hand. Title it and include labels for all materials on the materials list. 7. Data. Follow your test procedure and gather data, both observations and numbers, to determine whether the hypothesis is true, false, or inconclusive. Use proper units, titled data tables, and tape into lab notebook. 8. Conclusion. Use the data collected in the experiment to explain why the hypothesis is true, false, or inconclusive. Every conclusion must contain a minimum of 3 elements. 1. Restate your hypothesis. 2. Make a claim, true, false, or inconclusive. And 3. Use key points of data as evidence to support and explain your claim. Section 1. Matter's structure and function. Matter, structure, and properties. Before a materials scientist like Elliot Hawks can design a new synthetic material or choose a natural resource for a specific function, they have to have a basic understanding of matter, anything that has mass and takes up space. Mass is a physical property of matter. It is a measure of the amount of matter that makes up an object or substance, and it is measured in grams. To understand why a material has the properties it does, scientists begin with the atoms that make it up. An atom is the smallest piece of matter that has the properties of an element, substances that are made up entirely of one kind of atom. Atoms are so tiny that we cannot see them without special instruments. Because of this, scientists use scale to understand how atoms relate to everyday objects. Scale is the size, extent, or importance, magnitude, of something relative to something else. For example, think about all of the atoms that make up a grapefruit. If each atom were the size of a blueberry, the grapefruit would be the size of Earth. Aluminum foil is a synthetic material because it is created by humans. However, it is made from aluminum metal, which is a natural resource. Aluminum metal is made up of billions of aluminum atoms. Parts of an atom. Atoms themselves are made up of smaller particles. These particles include protons, neutrons, and electrons. These smaller particles are much smaller than the atom itself. The protons and neutrons group together in the nucleus. If you were to open up the blueberry, representing the atom, the nucleus would be too small to see. Scale of an atom's parts. If you were to make the blueberry the size of a football field, you would just be able to see the nucleus. It would be the size of a small marble. The nucleus is very dense because it holds all of the atom's protons and neutrons. Most of the atom's mass, 99.9%, comes from the protons and neutrons. The electrons are in the constant motion around the nucleus. However, most of the atom is filled with empty space. There are vast regions of space between each of the electrons and between the electrons and the nucleus. Scientists use what they know about an atom structure to create a scale model of an atom. Scale models are useful for scientists who want to understand the atom as a system and how the various parts of the atom interact. A system is a set of connected, interacting parts that form a more complex whole. An atom is a system made up of smaller interacting parts. This is a scaled model of an atom. This model of an atom isn't to scale. Its purpose is to show the relationship between the nucleus and the orbiting electrons. Scientists often don't work with individual atoms because they are too small to see without special instruments. Instead, they work with elements, such as a gold bar or helium gas. An element is a pure substance. This means it is made entirely of one kind of atom that has distinct properties that do not vary from sample to sample. It is the structure of the atom that make up a substance that give the substance the properties it has. Many of an element's properties are determined by the number of protons and neutrons its atoms have. Other properties are determined by an atom's number and arrangement of electrons. Most material scientists agree that the single most important event that happened in their field came in 1864. This is when Russian scientist Dmitry Mendeleev put together a chart called the periodic table of elements. This chart arranged all of the known elements according to their properties. When Mendeleev developed the periodic table, there were 63 known elements. His real genius was in predicting that elements existed that hadn't yet been discovered. His prediction was correct. There are currently 118 known elements, with the last 4 added just in 2016. These 118 elements are the only substances needed to make all of the materials that exist. In the human body, there are many billions of atoms, but scientists believe that more than 95% of the body is made up of just 6 elements: hydrogen, carbon, nitrogen, oxygen, phosphorus, and calcium. The first 94 elements are believed to occur naturally. The rest are synthetic. Most of the elements that have been created last only seconds at most before breaking apart into smaller elements. Scientists are continuing to search for new elements. Gold is an element made up of billions of gold atoms. Here's the periodic table of elements. Energy changes matter. In order to understand how materials scientists can create new materials with specific properties designed for a particular purpose, it is important to first understand the relationship between matter and energy. Matter can only change when enough energy is present. Energy is the ability to do work. Work is any change in position, speed, or state of matter due to force, a push or pull that acts on an object, changing its speed, direction, or shape. Examples of work include heating an object or moving an object. Energy can either be stored or in motion. Energy that is stored is called potential energy. The energy of motion is called kinetic energy. Energy is never created or destroyed, but it can change from one form to another. For example, all matter has a form of energy called thermal energy, which is the motion of atoms and molecules in a substance or object as its temperature increases. The faster that atoms and molecules move, the more thermal energy they have and the warmer they become. The amount of thermal energy present in a substance determines whether the substance is a solid, liquid, or gas, because thermal energy changes the motion of molecules. However, it doesn't change the chemical structure of the substance. For this reason, a change of state is considered a physical change. Whether you freeze or boil a cup of water, the water molecules are still water molecules. Thermal energy determines a substance's state. How are liquid water, ice, and water vapor related? How molecules form. All matter also has a form of potential energy that is stored in the bonds, holding together atoms and molecules. This is called chemical energy, and it is what allows new molecules to form. A molecule is a combination of 2 or more atoms bonded together. To bond means to join. Think of atoms like puzzle pieces, fitting together with other atoms to form bigger pieces of matter. Understanding the structure of atoms and how they combine is an important part of material science because each kind of material has the properties it does because of the number and kind of atoms that make it up. Examples of molecules. For example, oxygen is a molecule because it is made up of 2 oxygen atoms bonded together. Water is also a molecule because it is made up of 2 hydrogen atoms and 1 oxygen atom bonded together. Water is also an example of a pure substance because it is made up entirely of one kind of atom or molecule that has distinct properties that do not vary from sample to sample. With only 3 atoms, water is a small molecule. Other molecules can be much larger. One molecule of vitamin C is made up of 20 atoms, 6 carbon atoms, 8 hydrogen atoms, and 6 oxygen atoms. Some molecules are made up of many thousands of atoms bonded together. Chemical reactions. Molecules are formed as a result of a chemical reaction between 2 or more atoms. In a chemical reaction, the atoms that make up the original substances are rearranged into a new substance that has different properties from the original substance. For example, at normal room temperature, both oxygen and hydrogen elements are gases. When hydrogen and oxygen bond into a molecule of water, they change into a liquid instead of a gas at room temperature. These changes are chemical changes because they rearrange the chemical structure of the substances through a chemical reaction. In any chemical reaction, the atoms and molecules that interact together are called reactants. The atoms and molecules produced by the reaction are called products. When the reactants come together, energy breaks the bonds holding the reactants together and rearranges them to form new products. Molecules are formed in chemical reactions. In a chemical reaction, the product has different properties from the reactants. The total number of atoms does not change in a chemical reaction. Because of this, the mass of any one element at the beginning of a reaction will equal the mass of that element at the end of the reaction. This is called conservation of mass, which is the theory that states that matter is never created or destroyed. This means that the more reactants you add to the chemical reaction, the more products will form. It is always true that mass is conserved in a chemical reaction. However, this can be difficult to measure in the real world because matter can interact with the environment. For example, if a gas is produced in a chemical reaction, it will fill whatever space it is in. For this reason, scientists sometimes conduct closed system experiments so that matter cannot be exchanged with the environment. They do this when they want to isolate the reaction from the environment. Mass is conserved in a chemical reaction. The mass of any one element at the beginning of a reaction will equal the mass of that element at the end of the reaction. Energy in a chemical reaction. Together, the reactants and products form a system. The environment is everything else, including the air or any substance mixed with the reactants. It's important to note here that reactants are sometimes dissolved in other substances, such as water. The dissolving substance, such as the water, is called the solvent. When this occurs, the solvent in which the reactants are dissolved is part of the environment. The system of a chemical reaction interacts with the surrounding environment. As the reactants combine and rearrange, energy is exchanged between the system and the environment. Every chemical reaction needs energy to get started. This initial input of energy is called activation energy. For example, when someone strikes a match to light a candle, they provide the activation energy needed to start a fire, which is a chemical reaction. Once the reaction begins, some reactions absorb more energy from the environment than they release. Others release more energy into the environment than they absorb. Endothermic or exothermic. Whenever a process occurs in which the system absorbs heat, it is called endothermic. Endo means to draw in. In an endothermic reaction, the environment's temperature decreases. This is because the reaction has absorbed energy from the environment. When you strike a match, you provide the activation energy. Citric acid and baking soda combine in a chemical reaction. What evidence is there that this reaction is endothermic? Endothermic reactions occur because the reactants have less energy than the products. Because energy is never created or destroyed, the energy needed by the products come from the environment into the system. We can't observe these changes at the molecular level, but we can measure the temperature changes that results. We see evidence of this transfer of energy when the environment's temperature decreases because it means that the reaction has absorbed energy from the environment. exothermic processes. Any process in which the system loses heat to the environment is called exothermic. Exo means to give off. Because the energy is released as heat, the environment's temperature will increase. In an exothermic reaction, the reactants have more energy than the products. Because energy is never created or destroyed, the extra energy released by the reactants is transferred into the environment. Why is this graph showing an endothermic reaction? And why is this graph showing an exothermic reaction? There are many examples of exothermic chemical reactions. When you light a match, an exothermic reaction takes place. The light and heat produced are evidence that energy is being released into the environment. Another common example of exothermic reactions occurs in certain animals that produce and release light. Called bioluminescence, this phenomenon occurs in animals that live in the ocean, as well as some land animals such as fireflies. The strength of a chemical reaction can be measured by the amount of energy absorbed or released by the reaction. When more reactants are added, it increases the amount of energy that is absorbed or released. The light and heat of this flame are a result of an exothermic chemical reaction. The light produced by this firefly is a result of an exothermic chemical reaction. Section 2, designing materials. Discovering Teflon. One of the only surfaces that geckos can't stick to is Teflon, the material used in cooking pans to make them non-stick. Teflon was first discovered by accident in 1938 by a scientist named Roy Plunkett. Plunkett was trying to come up with a chemical to use in refrigerators. He decided to use a gas, which he stored in metal cans with a valve release, similar to hairspray cans today. On the morning he tried to release the gas from the can, Plunkett realized he couldn't get the gas out of the can. However, the can weighed the same as it had when the gas was added. Plunkett was curious as to what was going on. He cut open the metal can and discovered that the gas had turned into a white powder that was unusually slippery. Teflon is a synthetic polymer. Plunkett was intrigued. He tested the unknown white powder for its properties. He discovered that the white powder was heat resistant and had a low surface friction. This meant that most other substances wouldn't stick to it. That white powder would later be named Teflon. Without meaning to, Plunkett had produced a synthetic polymer. Polymers are large molecules that are made up of many smaller molecules bonded together in a repeating chain-like pattern. Polymers are all around us. DNA, spider silk, natural rubber, and protein are all examples of naturally occurring polymers. Plastics, nylon, acrylic, and Teflon are examples of synthetic polymers. Teflon is so slippery, it is one of the only surfaces geckos cannot stick to. Polymer structure and function. Teflon is so slippery because of its structure. It is a molecule because it is made up of the elements carbon and fluorine. The fluoride atoms completely surround the carbon atoms, so no other outside atoms can get near the carbon to react with it. It is this structure that makes geckos unable to stick to its surface. Properties of polymers. All polymers, including silk, Teflon, and nylon, share certain properties because they are all huge molecules. They have hundreds and sometimes thousands of atoms per molecule. Their structure gives them unique properties. For example, polymers are so large that they become entangled with each other. Think of one polymer molecule as a piece of cooked spaghetti. In a bowl of spaghetti, that one piece of cooked spaghetti gets tangled up with all of the other pieces of pasta. It is very difficult to separate one piece of spaghetti from the remaining pieces because the strands of spaghetti are tangled together. Polymer molecules are arranged in a similar way. This structure gives polymers some of their distinctive properties. For example, polymers are elastic, similar to how rubber bands are elastic. They can also flow, similar to how silly putty can flow. These properties occur because the polymer molecules can slide past one another, but they are still connected together. Teflon has the properties it does because of the kinds of atoms that make it up and how those atoms are bonded together. Another way of thinking about the structure of polymers is to picture a box filled with steel chains. Each chain is made up of hundreds of individual links, but the chains themselves are not connected to any other chain. In this example, each steel chain represents one polymer molecule made up of hundreds or thousands of atoms, chain links. If you were to reach into the box and grab a chain, you could pull out an individual chain. But now imagine that you add a lot of tiny magnets into the box. Those magnets would attract the steel chains, connecting the individual chains into one large mass of chains. If you were to reach into the box and grab a chain now, you would pull out the entire mass of chains. School glue and sodium borate. To understand how this applies to polymers, let's look at a simple chemical reaction between school glue and a substance called sodium borate, which is common in detergents and cosmetics. By itself, glue is a synthetic polymer made up of molecules of polyvinyl acetate. It is a sticky liquid. Sodium borate is a solid powder that can be dissolved in water. The glue is like the steel chains made up of long chains of molecules strung together. When you dissolve sodium borax in water and then add it to the glue, it has the same effect as adding the magnets to the steel chains. The sodium borate molecules react with the molecules of polyvinyl acetate, bonding at random places on the polyvinyl acetate molecule chain. The result is a new substance that is made up of tangled, long, flexible, cross-linked chains that are stretchy and bouncy. Polyvinyl acetate and sodium borate combine to form a polymer. Polymers are like steel chains. Experimenting with polymers. Understanding the relationship between a polymer's molecular structure and its properties allows material scientists to design new synthetic materials. For example, in 1930, several years before the surprise discovery of Teflon, a researcher named Wallace Carothers used his knowledge of polymers to create new synthetic materials that can be used in clothing. He wanted a material that was durable, flexible, and elastic. He had a good understanding of basic polymer structure. He knew that they were large molecules made up of long chains of repeating units of atoms, which gave them the properties he was interested in. He had been experimenting with synthetic polymers for 6 years. He and his team of researchers began by creating the first polyester fibers. These fibers became extremely elastic when cooled. However, this material wasn't very practical because it had a low melting point. This meant that laundering and ironing weren't possible. Nylon is discovered. So Carothers and his team kept experimenting with different chemicals in an effort to come up with the polymer that was flexible and sturdy, but also had a high melting point. 6 years later, they combined two chemicals, hexamethylene diamine and adipitic acid. When combined, a chemical reaction occurred that produced a gooey blob that could be drawn into long, thin, elastic fibers. Each molecule consists of 100 or more repeating units of carbon, hydrogen, and oxygen atoms strung in a chain. This was the first nylon. One of the reasons that nylon is so resilient is that a single strand may be made up of more than 1 million molecules. When stretched, each of those molecules takes some of the pressure. Nylon's molecular structure gives its properties. Section 3, manufacturing, making crayons. Twice a week, trains with cars full of paraffin wax pull up to the Crayola factory in Pennsylvania. Paraffin wax is a material that is made up of between 20 and 40 atoms of carbon, as well as hydrogen atoms. It is a white, odorless, tasteless, waxy, pliable solid. That paraffin wax is the main ingredient of crayons. Paraffin wax is a raw material because it is the basic material from which a product is made. Before you can buy crayons at the store and use them, the materials that make them up have to be processed. This operation of transforming raw materials into a finished product is called manufacturing. Manufacturing is what builds all of the stuff that surrounds you, from the nails and screws that hold your desk together to your cell phone, your clothes, and your car. Understanding the basic atomic structure of paraffin wax and its resulting properties is an important first step in manufacturing crayons. Nylon is another raw material that can be used in many different applications, including toothbrushes, women's stockings, and other clothing, carpets, hoses, parachutes, racket strings, and dental floss. Process is very important in manufacturing. Remember that a process is any series of steps designed to meet a goal. For example, the scientific process is designed to help scientists meet the goal of answering a question. Manufacturing processes refer to the series of steps designed to transform raw materials into a finished product. Different industries follow different processes, depending on the product being made. However, all manufacturing processes involve two basic goals. First, the materials have to be formed into the desired shape. Secondly, their properties have to be changed or improved to better achieve the desired function. When the trains reach Crayola's factory in Pennsylvania, the wax is heated until it melts. Here, it's important to know about more of paraffin wax's properties, including its melting point. Crayons melt at 40 degrees Celsius, or 104 degrees Fahrenheit. Then, the wax is mixed together with color pigments, which are like colored flour. For this step again, scientists need to know the properties of paraffin wax and how it interacts with other materials. Paraffin wax doesn't mix well with liquids, so the color pigment needs to be in solid powder form. Crayola makes 120 different colors of crayons. The wax is also mixed with other chemicals, which the company doesn't reveal. These ingredients give crayons the specific properties that they have. Crayon molds. Once the color pigments are mixed with the wax and stirred so the color is evenly distributed throughout, the hot wax mixture is poured into molding machines. A mold is a hollow container that is filled with liquid or pliable materials such as the heated wax or plastic. A single Crayola mold makes 1,200 crayons at a time. Cold water travels through the tubes in the molds to cool the wax down. When the material cools, it is hardened in the shape of the mold. This manufacturing process is often called forming. In forming, the shape of the material is changed into a specific form. In about 4 to 7 minutes, the wax in the mold cools and becomes solid. Workers scrape off the top of the mold and the extra wax will be melted and used again. The mold then extrudes the crayons. Extrusion refers to a manufacturing process in which material is put into a chamber and pressed out through a hole, also called a die. Extrusion is an example of a physical process because it doesn't change the chemical structure of the material. Other physical processes include cutting and sanding. Some processes are chemical because they change the chemical structure of a material. For example, some kinds of plastic are heated to make them more rigid. Nylon is cooled to make it more elastic. After they have been extruded, each crayon is inspected for breaks and chips, as well as for bubbles, which can appear if mixing has not been complete. Those crayons that are rejected will be remelted and molded. This process is called quality control. It is a process that reviews the fitness of production by comparing items produced to a production standard. This process includes product inspection, where someone examines the final product for unacceptable defects, such as cracks. Labeling crayons. Then, a machine puts labels on the crayons. Before 1943, farmers used to hand wrap the crayons during the winter months. However, using a machine allowed many more crayons to be labeled in a much shorter time period. People take crayons to a collating machine where 16 different colors of crayons are put together and mixed into a little box. More colors in more little boxes are added together in the final product. This process is called assembling, when all of the components are assembled into a whole product. Efficiency is an important factor at this point in the process. The fewer parts needed to assemble the product, the less time, and therefore lower costs it will take to put together. Additionally, manufacturers try to design parts that are easy to hold, move, and attach to decrease the amount of time needed to put all of the parts together. Crayola's manufacturing process is very efficient. It allows the company to manufacture 8,500 crayons per minute, 13.5 million crayons per day, and 3 billion crayons per year. It is so efficient because many of the processes are done by machines. Parts of the manufacturing process is assembling the crayons in the box. Manufacturing processes. Factories around the world manufacture many products that our society depends on, from crayons to medicine, cars, clothes, computers, phones, and construction equipment, to list just a few. In each of these factories, manufacturing processes are carefully followed. Manufacturers need to follow set processes because they want to make sure that the goods they produce meet certain design and safety standards. The process helps ensure that every step is properly followed and that the end products are equal in design, durability, and safety. Manufacturing processes depend on the materials used and the type of product being manufactured. For example, a company that makes a variety of different toys has a manufacturing process that has 65 major steps. Boeing is another company for whom a solid manufacturing process is essential. It has the largest building in the world, located in Everett, Washington. From this location, it has manufactured almost 4,000 airplanes. The main building covers 98.3 acres. In 2006, Boeing employees realized that they could improve the efficiency of their manufacturing process for their 777 airplane. In the traditional process, the airplanes being made remain stationary, parked wing to wing next to each other. However, employees realized that they could improve their process by switching to a moving assembly line, where the planes were positioned nose to tail so they could move. Having a process in place was important because the 777 airplane was about 3 million parts. When complete, it weighs 166,441 kilograms, or 366,940 pounds. Just the paint alone adds hundreds of pounds of weight to the plane. Painting is a part of finishing, the process when additional features are added to complete the look of a product. Painting and polishing are part of the finishing process, as is adding decorative features to the product. I hope you enjoyed reading Molecules to Materials and that you learned a lot. I'll see you in the next one. Bye.